Today's lecture is a continuation for what we have studied in the previous lecture of deep foundations. In the previous lecture, we took an introduction for the types of piles, method of installations, all the data related to the shape of the piles. We ended the lecture by a few slides as an introduction for the design of the piles. We said that for the pile resistance, what the pile can carry, we said that we have three main forces that the pile can carry: vertical compression load, vertical tension load, and horizontal load as a single pile. And we said that it's not always piles will be working as single piles, they can work in group, but in this case, based on what we have of our comparison with the person swimming in the swimming pool, that his efficiency for swimming will be affected, and at the same time the efficiency of the pile for swimming inside the water, the soil, will also be affected. So we have to study vertical compression, vertical tension, and lateral force also for the group, because it is not directly proportional. I cannot say a single pile can carry 100 tons. It means that if I have four piles, they will carry 400 tons. No, one pile will carry 100. Maybe 4 piles would carry 300, not 400. Why? Because the efficiency of the skin friction was decreased. So it varies from one place to the other. This was the first thing. The second thing, what we need to remember is what is the meaning of the end bearing and what is the meaning of the friction. These were the external forces acting on the pile: vertical compression, vertical tension, horizontal force, external forces acting on the pile. But here it's completely different. Regardless of what is acting on the pile itself, how much can it be carried by the soil? It's the opposite. This is the reaction. The previous slide was the action on the pile. Here, the soil reaction to the pile. So we have two types of soil reaction. It's either end bearing or friction. And we said the example of carrying the bag. You can carry it from the bottom, or you can just put your hands around the bag and you can carry it. So you can carry the bag by friction, or you can carry the bag just by bearing, by putting the bag on top of your hand. So this is, or you can carry the bag with two hands, one around the bag and one at the bottom. So in this case, it is not always pile resistance, pure point end bearing or pure friction. No, it is always a combination of both. Maybe it would be, say, 10% friction and 90% end bearing, or the opposite, or 50-50. It depends on the type of soil layers, because it is not always one layer. Pile may penetrate 5 to 10 layers. In each layer, you have a different combination of loading, but the end bearing will always be in the bottom layer. All the layers will carry friction. But when I come to the last layer before the end of the pile, this is the layer that is carrying friction and end bearing. If I have a small layer here at the bottom, this layer will be carrying, imagine that this line is a little bit high. So this layer is carrying friction along this side and end bearing at the bottom. but all the top layers are carrying friction only. Bearing capacity of single pile, this is the start of our lecture. Bearing capacity of single pile under vertical compression load. This is the first thing. By the way, do you think what will be the difference between vertical compression load and vertical tension load? If I have this pile or this pile and I have compression load on top of it or tension load, what do you expect the difference will be in the behavior of the pile? Can anybody of you think what would be the difference if the pile, if I have a pile that is subjected to 100 ton vertical compression and another pile subjected to 100 ton vertical tension, is it the same? Will the reaction of the soil be the same? Why? What will be affected? What is the main item that will be affected? Yeah? Yes, but for the friction, if I'm carrying this bag and the bag wants to slip down, or somebody wants to grab it up, if I'm holding it very tight, nobody will take it, either up or down. So for friction, it does not matter what is the direction. If there is friction between this item and the table, if you push it like this, there will be friction. If you push it like this, there will be the same friction. But if this item is end bearing on this table, then the load is going here. But if I use tension, I push it up, what is the connection between it and what is below it? Nothing. Imagine in this photo, this is the load, this is a compression load. And here also, this is the load, this is a compression load. When this load go down for end bearing, this hand or this layer will be carrying the load. But imagine I change this load from being compression to being tension. What will happen here? Nothing. Nothing. Because the hand will not grab the pile down. But here, these hands will grab the pile down because they still have friction. But here, the end bearing will be zero. So this is the main difference between end bearing and friction. If I have a pile and I studied the friction and I found that the friction is 50 ton. Yani, according to friction, the pile can carry 50 ton. And according to end bearing, the pile can carry 40 tons. If I have a tension load, what is the maximum that the pile can carry? It is the 50 of the friction. But the 40 of the end bearing will be zero because they will not work in tension case. So this is the main difference. For design, it is very easy because for us, we design the load according to friction, we design the load according to end bearing. If you tell me what is the allowable compression load, I will add both. If you tell me what is the allowable tension load, I will take the friction only and tell you that this is not available for end bearing. So the first thing is bearing capacity of single pile under vertical compression load. The bearing capacity of a geotechnical pile is calculated in several methods. Then it is compared to the capacity of the concrete pile to bear load in a state of compression, or the capacity of steel bar and so on, and I will tell you what this means, and take the smaller as the example will demonstrate. For the bearing capacity of a single pile under compression load, I will carry the load according to friction, and I will carry the load according to end bearing. There are many methods. This is what we are going to see. And then I will sum them together and I will tell you that this is the capacity of the pile. Sometimes the capacity of the pile is more than what the pile can carry as a concrete section. If I have a column, I can tell you that this column can carry 100 tons. If you subject it to 120, it's unsafe or it may fail. So there is a limit for the concrete section to carry load. But I studied the pile. Actually, I did not study the pile. When I study the pile and say that the capacity of the pile is so and so, I am defining what? I'm defining the soil. I'm saying that this layer has C and phi, and this layer has C and phi, and this layer and so on, and I calculate something and I tell you that the pile can carry this amount. Actually, this is not the carrying capacity of the pile. It's the carrying capacity of the soil to carry the pile. In case the pile, imagine that you have a pile made of concrete, pile made of steel, pile made of glass. Of course, each pile will carry a different load, regardless of what the soil can carry. The soil can carry a certain amount of load, but the concrete section itself may be less. So I have to calculate both and to choose the smaller. If the soil can carry 100 tons, but the pile cannot carry except 80, then the load coming should not be more than 80, because if 100 tons pass by the pile, they will break it and then go to the soil. The soil will carry the 100 tons, but the pile will be destroyed. So I cannot do this. And the opposite, if the pile can carry more, okay, it will carry 120. But what the soil can carry from this 120 is only 100. So the pile should not carry more than 100. Okay, so I always choose what is smaller. This is the general idea for the design. According to the Egyptian code, they gave me many methods for the design. By the way, as an introduction, all methods of design are okay. You can use any method for design, but take into consideration that each method will give you a number. And this number will be sharply different than the other. If I use method number 1, it will give me 100 tons. If I use method number 2, it will give me 120. Which is correct? I don't know. So, what is my guide for this? If I use another method, it may give me 140. How come 120 and 140 and 100? Which one to use? Use anyone you want. But you will have to perform or to conduct a pile load test on site. This is the governing for me, because anything you are going to calculate is just approximation. I will say that this pile will carry 200 tons. Then I will design, all my design will be based on 100 tons or 200 tons, whatever the number is. And then I go to the site. I may conduct or construct a pile similar exactly to the pile that will be used in my building, and make a full load test on this pile, and I load it till it fails. So this is the exact, this is 100% correct. And I compare this to my design. If it is less than my design, then it is unsafe and I have to increase the number of piles. If it is more, I will not take the more. I will take only what I have designed. This is my rule. So this is what we mean. We do. The first equation given by the first method given by the code is for piles that are less than of a pile diameter less than 60 centimeters. So any pile from 60 to anything less than 60, I can use this method. As we said in the previous slides, the load, the ultimate load that will be carried by the pile has two ingredients inside. What are these? The friction and the bearing, the end bearing. So I should have an equation for friction and I should have an equation for bearing. This is the equation given for bearing. This is the equation given for friction. If we look at the equation, this is the combined equation. Yes. If I have a diameter that is more than 60, I have to go to the next method that we are going to discuss later. But so far, this is up till 60 centimeters. Why? Because whoever who presented this equation is depending on maybe more on the friction. If the diameter increases, then the bearing performance will differ. It's not important, but what is important that we follow the limitations given by any rule. This is my equation, and the limitation of it is for 60 or less. That's all. If you look at the equations, this or this, you will find that Q bearing or Q friction is a stress. Usually, no, I don't mean it's a stress. It's a load. This is the load coming from bearing, and this is the load coming from friction. How to know the equation that this is the load coming from bearing and the load coming from friction? If you look at the items here, you will find many things. C, N, C, P, B, N, Q. We'll discuss this later. But multiplied by what? Multiplied by the area pile gross section. Area of the gross, yani it means the area of the pile. The other one is multiplied by the area of the sides. Without looking, if something is multiplied by the area of the pile and something is multiplied by the area of the sides, which one is for friction and which one is for end bearing? Sides for friction and cross section for end bearing. So it means that we are multiplying something here resembling the stress. If you multiply the stress by the area, you get the load. And here is something also resembling the stress, and it is multiplied by another area to get the load. We add both loads together to get the ultimate load that the pile can carry. So this is the combined equation. To use this combined equation, we have to know all the items that are included here. So you will find that this is what I can say, that it's a slide that is combining everything together. Don't concentrate on the numbers, because each table or each one of these will be shown in a separate slide. But this is just an introduction. This is my full equation. Here is the area side. This is the value of the area side. It's area 2 pi r multiplied by the length of the pile, or the length of the layer. Here area pile pi r squared. These are constants. But if you look here, you will find here something called C. C is the C of the soil. But there is something here also called CA. Look at this and look at this, you will find that both are more or less the same table. Because in the code, you will have a table, this table, this one. This is a table given by the code, giving the value of C. This is the value of C, and this is the value of CA, based on the type of the pile and the type of soil. If I have here wood or concrete, or if I have here steel, then these I have to choose first. Say I have a concrete pile, then it is here, خرسانة, it means concrete. But by the way, this is the translation of this table, exactly the exact translation of the table. So, but I prefer usually to discuss what I need on the table that you will use in case you are working in the office. The translation may not be with you. So this is the translation in case you need to translate anything, but this is the table given in the code. So I need here, it is concrete. What about the soil? This is very loose, here loose, here medium loose, here a little bit stiff, very stiff, and so on. So what do you consider your soil? If I have very good sand, I will consider that this maybe here it is stiff or good soil, cohesive. Not cohesive, but يعني in the sense of cohesion. Then I go here, he will give me a number for CA or a range for CA and a range for C and for CA. Then I can take these, go back to my formula. Here C, I put a number. Here CA or the opposite. Here CA I put a number, and here C I put a number, and so on. NC, you will find that the bearing capacity factor and its value is usually equal to 9. So it is always equal to 9. I don't have to go to any place.
So they both have the same, the C, they both have the same value?
Yes. Yes. What C?
C and the C. The ones that
NC in this equation is always equal to 9.
No, I'm talking about the C and the CA.
C and CA, you take it from here.
They both have the same value.
No. See, this is C and this is CA.
Okay.
If you look here at this line, they are the same. But if you go below here from 10 to 20, and here from 47.5 to 56 or 65. So it depends on the number. Okay? Is there a problem in that? Okay. And so on. We will take each factor. This is PB. What is PB? P is the effective stress of the soil at the location that we want to study. The location is here. Consider these two factors. This is PB and this is P naught. PB is in the portion of the equation that is multiplied by the area. It means that it is in the portion of the equation that discusses the end bearing. So PB is P related to end bearing. And here P naught multiplied by the area of the side, so it's related to friction. What are these? Let us discuss here. If I want to study the pressure of the soil on the portion of the soil that is carrying end bearing. The pressure of the soil is all of this length. All of the soil on top, from the bottom of the pile till the top of the pile, or even till ground surface, are pushing or pressurizing the soil at the bottom. So B, which is P at the base, is the pressure that I need to calculate. So what is the pressure? Gamma H. If I have one layer, so it is gamma of this layer multiplied by the H. If I have two layers, then gamma H1 or gamma 1 H1 plus gamma 2 H2 and so on. So this is PB. If I am considering the friction, the pressure here is different from there, is different from there. So what should I do? I should do something average. I will take it at the middle of the height. So in case here PB It's the effective soil vertical pressure at the bottom of the pile. You know now why it is at the bottom of the pile, because I'm concerned with the end bearing, and the end bearing is affected by all what is above. Here, P note, effective soil vertical pressure at the middle level of the layer. So it means it's not the middle pile, at the middle of the pile, it's if this is the bottom of the pile and this is the ground surface and it is one layer, then I will take this distance divided by 2 at the middle exactly. I will check the stress gamma h, which is this h, the middle of the layer. If I have many layers, then I will study for each layer the stress at the midpoint of this layer. Okay, so this is the next parameter, which is P note or PB. Then I have something called NQ. NQ, this is the shape of the table of NQ. I go down, this is here it is NQ. This is the table of NQ. You will find that NQ is given related to the phi of the soil. If I have soil with phi, say 30, then NQ will be, say, 30. If I have 35, then NQ will be 75, and so on. So I take from this table the value of NQ that I require, and I put it and insert it here. So now I have NQ, PB I calculated at the bottom of the pile, NC I get it equal to 9, C I get it from the table showing C and CA. And then I go, this is the area of the pile, I can calculate it, and so on. I go to the next section. From the next section, I already know CA, and I already know P note. What is remaining? What is remaining is delta and KHC. KHC, there is a table for KHC. This is the shape of the table of KHC. I go down to find where is KHC. Where is KHC? This is KHC. Yes, this is KHC. So I go here to KHC, depending on the type of the pile. Is it driven? Is it a board? And so on. I get a number. I choose whatever I feel is better. Here he tells me, say, you have board pile, and the value of KHC is between 0.7 to 1.5. If you don't have something to favor one, then take the one at the middle, the average of both. But if you find that it is bored, but it is not really bored because there is something was wrong in the construction of this pile, then I would take maybe the less value. It depends on your engineering judgment.
Yes, yeah. For this table, unknown judges.
Yes, yes.
The type of pile.
Yes. No, it is given. Of course, in the yes. No, but I'm speaking about in normal life. If you are designing a pile, then you know the conditions and you know the contractors who's working. If you have a very good contractor, then take higher values. If you have intermediate contractor, take an intermediate value, and so on. So these are the second thing. This is KHC. Delta. There is also a table for delta. I go to the table of delta. Where is the table of delta? This is the table of delta. Depending on the type of the pile, steel or concrete or wood, and then I take the value. If you look at the value, you will find that the value is an equation. It relates delta to phi. So here it is 3/4 of phi. I know the phi of the soil, then I can get delta. If you see, I discussed everything, but I should not have discussed it because this is something very trivial. I go to a table, get a number, insert the number in the equation. So it is, and usually in an exam, I will not give you all of these table for you to check a number. I will give you the numbers, but in the coursework you have to do it yourself. In the tutorial you have to do it yourself. So we're just discussing how to do it as if we are really designing a pile in our normal life. And so on. These are all, here is the area of the sides. We already calculated it before. So I will insert all the numbers in this equation to get Q ultimate. It means that you have Q ultimate. If I am doing this example, I would split it into two. I will take the part for the that is multiplied by the area side alone, and I will take the part that is multiplied by the area of the pile alone, so that I can have the sense of feeling what is the value carried by the end bearing and what is the value carried by the friction, and then I will add them together. When I add them together, then I get the ultimate load carried by this pile. Okay, all of these are just tables and charts from the code that help me in the design. To understand this, we have to go to an example. This is an example. This is the pile we have. It penetrates 3 layers. The first layer, sandy silt. Second layer is silty clay. The third layer is sand. First, we have to discuss which layer will carry end bearing and which layer will carry friction. Can anybody of you tell me? Bottom layer will carry end bearing. What about the friction? All of them. So it means that the bottom layer will carry two things. Will carry end bearing and will carry friction. Because here, end bearing. This 2 meters will carry friction. And if I go up, these 4 meters will carry friction only. These, I don't see here, is it 8 meter or something like this, or 5 meters? Then these 5 meters will carry friction. So I calculate each one alone. So it means that this equation, here I'm going to use it, but I will use parts of the equation. I will not use the full equation. I will use the part. I will take the part for bearing alone, and I will take the part for friction alone. The part for friction, I will use it 3 times. The part for end bearing, I will use it once. And then I will add the 4 values to get the ultimate load carried by the pile. The only difference you have it is easy. The only difference you have to take in mind is what is P naught and what is PB. You remember we said PB is at the bottom. P naught is in the middle of the layer, but I have here three layers. Then I will have to calculate it 3 times. Where? Let's see where. Where is the, yes, here. For this layer, PB is here. It is very straightforward. But P naught is here at the middle of the layer. What about the upper layer? P naught is here at the middle of this layer. Here, P naught is here at the middle of this layer. What is the starting point? The starting point is the ground surface, not the start of the pile. So if this point is here and I want to calculate P naught, then P naught is 5 divided by 2 plus 1.5. You understand that? 6.5. Pardon? 6.5. No, not 6.5 over 2, because you calculate the middle of the layer first. This is the middle of the layer. So it is 5 divided by 2. This is the middle of the layer. But what is the depth of this middle of the layer? It is the top of the layer plus the upper layer. It's just a load on the. It has nothing to do with the pile itself, because this 1.5 meter is a load on top of the pile, but it is not the middle of the layer. The middle of the layer is from the start of the pile to the end of the layer. This is the middle of the layer. So it is at this point. What is the depth of this point? It is from here to there, which is 5 divided by 2, plus 1.5. So 1.5 is not included in any middle. It is just an additional load on the pile. This is the only difference that we will do here. I will start by calculating what is called a geotechnical capacity. What does a geotechnical capacity mean? What the soil can carry, not the pile. Because we usually misunderstand this. The pile, when it is carried by the soil, then the soil is the carrying, not the pile. The pile will carry later when I come to study as a concrete section how much does it carry at the end of my calculations. But now I'm calculating what the soil can carry from this pile. So, as I said, I will calculate bearing once and friction 3 times. I will add them together. So I have to put, first I will say Q bearing for sand, and I put the equation for sand, and the equation for sand will be because it is bearing multiplied by the area of the area gross of the pile. So this is the area of the pile. I will start with my layer. The layer is sand. Because it is given that it is sand, it means that C equals to 0. Then I don't have to calculate CA and C and so on. C is equal to 0. So because it is sand, it only includes phi. Then I calculate PB, the same as we said, how to calculate PB. Add the bottom of the pile and I get the depth of this bottom by adding the thicknesses of all layers plus the top layer that is above the pile cap. I add them all together and calculate PB. And then I note here that it was introduced gamma equal 10 for the this is important because there is a level for water here. So when I come to calculate the effective stress on the base, say, so it will be affected by this layer in a submerged form, and it will be affected by this layer in a bulk form, in its natural form. So here I will use gamma for soil, which is 16 as given. But here and here and here, I will have to subtract 10 minus the gamma of soil because it is submerged. Do you remember what we studied last year? Effective and total. I'm not fond of, or I'm not keen to study what is the total stress. I am studying the effective stress. What is really affecting my soil? I don't care for what is affecting my water. So what is really affecting my soil is the submerged gamma, which is, for this case, it will be 17.5 minus 10, which is gamma of water. And here it is 19 minus 10, also 10 is the gamma of water, and so on. So this is what you have to take into consideration, that we, to calculate this, we multiplied here, first layer multiplied by 16, second layer multiplied by 7.5 instead of 17.5, third layer by 9 instead of 19, and here 2 by 8.2 so instead of 18.2, and so on.
So this one is for the area.
Pardon?
I think this one is for the area. The area for the section is not for the column.
Which one? No. 8.2. Let's see here. Where is 8.2? Here is 18.2. Yes. Here is 18.2, it will be 8.2. Here is 19, it will be 9. Here is 17.5, it will be 7. Here is 16, it will remain 16 because it is above water level. So this is to calculate PB. If you want to calculate P naught at this layer, then I will calculate half this layer multiplied by gamma submerged, which is multiplied by 9, and then this whole layer multiplied by 7.5, and this full layer multiplied by 16. I mean, it's a normal substitution. I'm not the main idea is that if you are calculating the effective stress at any point, just check where is the level of water. Anything below the level of water, I should subtract the gamma water, which is 10 in our units, and anything above the water, I will take it as it is. So these are just a normal substitution in the equations. Here we are discussing something that it was taken from a table. I have a value of phi that is between two values. How to calculate it exactly? Say the table tells you that for phi between 30 and 40, the value of NQ is between 100 and 120. Between 30 and 40, the value of phi, if I tell you that the value of phi is 35, then without calculation 35 is in the middle, then I go to the value of NQ, I take the middle value. If it is 100 to 120, I will tell you NQ equal 110. But suppose it is not at the middle, then you have to use ratio and proportion. This is how we use the ratio and proportion. But of course, I should not give it to you, but I just give it so that you know from where I got this value. But for you, you can even calculate it by drawing if you want. Just put a number at the start and one number at the end. Take an inclined line and take any point anywhere in between and go up. Draw a chart. Very easy. You can get it. But of course, it is best thing to calculate it by ratio and proportion. And so on. This is the area, and I multiplied, then this is Q bearing for sand, I will calculate multiply it by the area, and so on. I will go, you have to check it first with your hand, then if you have further questions we can discuss. But here, this is given, as I said, step by step, every number how I got it from the table. You can just check it for yourself. Then I will calculate for each layer. As I said, this is the third value that I have calculated, the friction for silty clay, and so on. The fourth one is the friction for sand, and then I reach what is the ultimate. My ultimate is 1 plus 2 plus 3 plus 4. Then I will put the four numbers, take the sum, then this sum is the maximum ultimate load carried by the soil for this pile. This is the exact definition of what we have said. We have calculated the ultimate load the soil can carry from this pile. But this is the ultimate. What is the relation between the ultimate and the allowable? It's a factor of safety. Usually, we have two ways for giving the factor of safety. Sometimes, which is the easiest way, they tell me that take factor of safety of 3, and so or 2.5. Then I will take this number, divided by 3, then this is the allowable, straightforward. But suppose I tell you, and this happens in some codes, they tell you take a factor of safety for friction equal to so and so, and for end bearing equal to another value. Then in this case, I will have to take Instead of 1 plus 2 plus 3 plus 4, I will take 1 alone, which is the, suppose that 1 is the end bearing. I will divide it by the factor of safety for friction, for end bearing, and then I will take these 3 together and divide it by the factor of safety for friction. It depends. And the logic is that it differs. The factor of safety for friction is different from the factor of safety for end bearing. So to be accurate, I have to give you 2 numbers. But usually they consider that the contribution is the friction and the contribution is of the end bearing are equal to each other. So let's take 1 number and so on. But the best thing is to give you 2 numbers and you have to divide each one with his corresponding number for factor of safety. Then, so far, I have used what is the soil is carrying. We said that we have another thing, what the pile can carry itself. Maybe the pile cannot carry this 611. We said that now it's 611 kilonewton. Maybe the pile as a concrete section would break in case it reaches 611. So I have to check a concrete section. So I take the area of the pile, multiply it by FCA of the concrete, I will get a number. This number happened to be less than the 611. It is 565. So in this case, what is governing me is the pile as a concrete section, not what I have studied for the pile itself, for the soil. The soil can carry 611, but the pile can only carry 565. So what is the carrying capacity of this pile? What is the allowable load for this pile? It is 565. This is the end of this example and the end of this lecture. We have taken a case for piles that is less than 60 centimeters. In the next lecture, we are going to study a case of large diameter piles where the piles are more than 60 meters, and we will study with example as well. But for the time being, now you can calculate any pile that is less than 60 centimeter without any problem by just usual substitution in 2 equations, more or less. Thank you and see you next lecture.